Okay, in this presentation we are going to look at continuous random variables. What we have here is a random variable x, and it's a continuous random variable, and it has the following probability density function. We denote probability density functions as lowercase f of x, small f of x. In this particular case, the probability density function is 1 minus x squared times 3 over 2 when x is between 0 and 1 and 0 elsewhere. Okay, so essentially what we could do here is we can concentrate on this range of values between 0 and 1, and that would be appropriate for our answer. So what we can do now, there's two questions. Show that the PDF, the probability density function of x, is properly defined for the interval 0 to 1, and show that find the expected value of x. Okay, so this is the first part, what we have to do here. So this is the identity that we're going to use. So by definition, this is the definition of a probability density function, and how it relates to probability is that the integral from over all the possible range of values. Now in the extreme case, that would be minus infinity to infinity. The integral of that of f of x dx should equal to 1. Now we can just concentrate on the range of values we were given, because we know it's 0 elsewhere outside that range of values, so necessarily the integral will just evaluate to 0. So what we could do here is just concentrate on the range of values from 0 to 1, get the integral of that. So it's a definite integral from 0 to 1 of f of x dx, and that should equal to 1. Okay, so that's what we have to do here. So this is our probability density function there. 1 minus x squared times 3 over 2 dx, and that is the integral from 0 to 1. So what we can do here is take out 3 over 2 as a constant. Okay, so just bring it out and just disregard that there. So what we're left with here is an integral 1 minus x squared. That should be straightforward enough, really. So when we integrate that, we get x minus x cubed over 3. So what we have now is a definite integral between 0 and 1. Okay, so 1 minus 1 over 3, that is what we get when we integrate or evaluate our definite integral at 1. If we integrate it at 0, we would get 0 minus 0, which we can just disregard. Always check that through, though. Okay, that when you evaluate at 0, that you should get 0 and you can disregard it, because don't automatically assume that. Anyway, we can in this case. So 1 minus 1/3 is 2/3. So 3 over 2 times 2/3 is simply 1. So yes, we have a properly defined probability density function that will evaluate over the definite integral as 1, which is what it's supposed to do. Okay, now find the expected value of x. This is the definition we would use. The expected value of x equals the integral from the lower bound to the upper bound of x times f of x dx. Okay, so essentially same thing again. What we do here is just we have x times f of x rather than just f of x when we integrate. So again, we can adjust our limits of integration to 0 and 1 as the lower limit and the upper limit respectively, because otherwise outside that range of values the integral would just be 0. So we can just sort of concentrate on that only. So we have a definite integral of x times 1 minus x squared times 3 over 2. And again, we can bring 3 over 2 outside the expression. When we multiply x times 1 minus x squared, then we get x minus x cubed. So again, a very straightforward definite integral here. And we do it more or less the same way. So we have the 3 over 2 outside our expression. We'll just sort of keep that until the end. So when we get this definite integral, x minus x cubed, when we integrate that, we get x squared over 2 minus x to the power of 4 divided by 4, and evaluate that at 1 and 0 and get the difference. So when we evaluate at 1, we get 1 squared divided by 2 minus 1 squared divided by, that should actually be equal to 4, I apologize. And likewise, evaluated at 0, we get 0 squared divided by 2 minus 0 squared 0 to the power of 4. Again, that's another little error there. Anyway, so that just simplifies to 0. So what we end up with is a half minus a quarter, which is actually minus 0, which is just equal to a quarter, 1 over 4. So 3 over 2 times 1 over 4, that gives us 3 over 8. That is the expected value of x. Okay, we'll leave it there.